In this video, I want to talk about using synthetic division to divide a polynomial by a very specific linear binomial. So traditionally, this divisor must be in the form x minus k. And so in this case, it looks like the k value is going to be 3. And so the way we're going to use this is we're going to focus solely on the coefficients of this polynomial. We're going to break it down, do the work on it, and then at the end build it back up again. So we're dividing by this linear binomial, and again, x minus k is the form that traditionally this needs to be in, and in this case our k is 3. So I'm going to go ahead and put that k value out front, and I'm going to do a little bar here. And basically it's just an upside down division bar from our standard division algorithm. And then here, what I care most about are the coefficients of these terms and then the constant. And so I'm just going to write the coefficients in here. So the x to the fourth term has an 8. The x cubed term is a negative 27. The x squared term is a positive 15. The linear term, this x term, is negative 20, and then finally our constant is 6. And I'm in the habit always of putting this little bar right down here after I write these out, because this represents my remainder. And remember, if your remainder is 0, then it means that this linear binomial x minus 3 in this case will divide evenly into this polynomial. And if there is a remainder, we'll have to deal with that. So we're going to do two examples in this video. One, of course, without a remainder, and then the second one will have a remainder, and we'll talk about how to deal with that. So here's how our synthetic division is going to work. I'm going to go ahead and bring down this leading coefficient, so whatever it is, so 8 right there. And now we're going to go through a series of multiplications and additions on these columns. So this 3 is going to keep coming back over and over again. So 3 times 8 is 24, and we're going to go ahead and put that in this open space right there. And then we're going to add these two values in this column. So negative 27 plus 24 is negative 3. Okay, same thing again. I'm going to multiply here. So 3 times negative 3 is negative 9. I'm going to put that in the open space here. And then I'm going to add down this column. So 15 minus 9 is 6. Okay, so a multiplication again, 3 times 6 is 18. Put that 18 in that open space there. And then add this column. Negative 20 plus 18 is negative 2. And finally, this multiplication, 3 times negative 2 is negative 6. And adding these will leave us with a 0. Okay, well that's good. That means there is no remainder. And that means, of course, that x minus 3 divides this nicely. Okay, well, now I've got a bunch of numbers right here. These numbers are going to be the coefficients and the constant of our new polynomial, which is the quotient here. So this column will be our constant, and then we'll build it up by saying linear, quadratic, and cubic. And you can just work from right to left, building that up. And of course, we knew that the x cubed term would be the highest degree term because we're dividing a quartic, this x to the fourth, by a linear binomial, and 4 minus 1 is 3 right there. Okay, so let's go ahead and write this. It's 8x cubed minus 3x squared plus 6x, and again we put the plus because this is positive, and then minus 2 for our constant right there. And so here we have the quotient, and this is just kind of an alternative approach to using long division for polynomials. But once again, this is good traditionally for linear binomials in the form x minus k. And I'll show you another video where we can actually go ahead and put a leading coefficient other than 1 here, and I have linked to that down in the description for this video. So here's this first example. Let's go ahead and work through a second example. So notice here that our divisor, again, is a linear binomial, and we need this to be in the form x minus k so I can get my k value. Well, it looks like this is x plus 6, so to force it to be in this form, we'll have to turn this addition sign into double negatives here. So now I can say it's x minus a negative 6, and that means our k value then is that negative 6. Okay, so see how we kind of broke that down from that x plus 6 to x minus a negative 6. So our k value then is negative 6. Okay, so let's go ahead and bring that negative 6 out here then. And let's go ahead and kind of prepare our algorithm. And again, we are concerned with these coefficients for the synthetic division and our constant. So our x to the fourth term is going to be negative 2. Our cubic term is negative 7. Quadratic term is 21. We have our linear term with negative 52, and then our constant with 9. And of course, I always put this little bar here, and once again, that's our remainder if we happen to have one. And the last example did not, and this example will, and we'll go ahead and show you how to deal with that. Okay, so what are we going to do first? Well, bring down this leading coefficient here. And now we're going to go through a series of multiplications and additions. So negative 6 times negative 2 is positive 12, and I'll put that in that first open spot. And then I'll go ahead and add this column. So negative 7 plus 12 is 5. Negative 6 times 5 is negative 30, and when I add that column, I get negative 9. And let's go ahead and multiply and put that here. So negative 52 plus 54 is positive 2. And finally, this last multiplication will give us negative 12. And when I add, that'll give us negative 3. So we do have a remainder in this example. Let's go ahead and build this back up. So here's our remainder. This guy is our constant, our linear term, our quadratic, and our cubic terms. So we'll go ahead and say negative 2x cubed plus 5x squared minus 9x plus 2 for our constant. And now we have to deal with this remainder. So he's negative, so I'm going to say minus. And if it was positive, I'd say plus, of course. So it's minus, and then I'm going to put this 3 over, and then I need to go grab my divisor right here. So x plus 6. And this is the way we are going to do the synthetic division when there is a remainder. So just go ahead and put that remainder over our divisor. So in this case, we divided a polynomial by a binomial, and our quotient was not a polynomial.